Good afternoon. The program is stepper motor interfacing with 8051 microcontroller. So first we will see what is stepper motor. Now stepper motor is a brushless DC motor. Stepper motor means what? It is a brushless DC motor which can be rotated in a small angle. It is a brushless DC motor and it can be rotated in small angle, and these angles are called as steps. So generally stepper motor use 200 steps to complete cycle, or we can say to complete the 360 degree rotation. That means it rotates 1.8 degree per step. To complete 360 degree there are 200 steps, that is stepper motor required use 200 steps. So it rotates 1.8 degree per step. Now the stepper motor is used in many devices which needs a precise rotational movement like robot, antennas, hard drives, etc. And we can rotate a stepper motor to any particular angle by giving it a proper instruction. So basically it is a brushless DC motor. It requires 200 steps to complete a 360 degree, and it means it's rotate 1.8 degree per step, and it is used in the devices which needs a precise rotational movement like robot, antenna, hard drives, etc. So next is the stepper motors. Basically stepper motors are of the two types, that is unipolar and bipolar. Stepper motors are of the two types, that is unipolar and bipolar. Now what is unipolar? The unipolar stepper motor generally has 5 or 6 wires, in which 4 wires are one end of the 4 stator coil and other end of all 4 coils is tied together, which represent 5th wire, and this is called as a common wire. Unipolar stepper motor generally has 5 or 6 wires, in which 4 wires are one end of the 4 stator coil and other end of all 4 coil is tied together, which represent a 5th wire, and this is called as a common wire or common point. So generally there are 2 common wires which are formed by connecting one end of the 2 coil, which is shown in this diagram. This diagram shows the unipolar stepper motor. Here there are 2 common wires which are formed by connecting one end of the 2 coil. A unipolar stepper motor is very common and popular because of its ease of use. It is easy to use, so stepper motor is very common. So this diagram shows the unipolar stepper motor. It consists of coil 1, 2, 3 and 4, and at the center there is a rotator, or we can say a permanent magnet. The power supply is given. It is a common wire for A and B coils and for D and C coils. Now the next is bipolar stepper motor. So Now next is bipolar stepper motor. So bipolar stepper motor, there is just 4 wires which are coming out from 2 sides of the coil. That means there are no common wire. In unipolar there are common wires. In bipolar there are no common wires. So stepper motor is made up of stator and rotator. Stator is stationary part, rotor is rotating part. Now stator represent 4 electromagnet coils which remain stationary around the rotator. And what is rotator? Rotator represent permanent magnet which rotates. That is, stator is stationary part, rotor is rotating part. So whenever the coil energized by applying the current, the electromagnetic field is created, which results in the rotation of the rotor. Rotation of the rotator means the permanent magnet. So the coil should be energized in a particular sequence to make the rotator rotate. So on the basis of this sequence, we can divide the working method of unipolar stepper motor in 3 modes, that is wave drive mode, full step drive mode and half step drive mode. So on the basis of the sequence, we can divide the working of unipolar stepper motor in 3 mode: wave drive mode, full step drive mode and half step drive mode. Then wave drive mode means what? In this mode, one coil is energized at a time. What is wave drive mode? In this mode, one coil is energized at a time and all 4 coils are energized one after the another. So it produces a less torque in compare with a full step drive mode, but the power consumption is less. So following is the table. This table shows for producing this mode using microcontroller. That means we need to give a logic 1 to the coil in the sequential manner. Now here are the steps in which logic 1 is given to the coils A, B, C, D in sequential manner. So this is wave drive mode. Then the next is full drive mode. Now what is full drive mode? So in this mode, the 2 coils are energized at the same time, producing high torque and power consumption is higher. So we need to give a logic 1 to the 2 coil at the same time. In wave drive mode, we have to give a logic 1 to the 1 coil at a time, and in full drive we have to give a logic 1 to the 2 coil at the same time, then to the next 2 coils and so on. So here are the steps given in this table which shows The ABCD are the 4 coils. In step 1, the logic 1 is given to the coils A and B. Then in step 2 to the B and C coil. Step 3 is C and D, and the step 4 is to coils A and D. Logic 1 is given. So this is the main difference between the wave drive. This is the difference between the wave drive and the full drive, that the logic 1 is given to the one coil at a time in wave drive, and logic 1 is given to the 2 coils at the same time in the full drive. Then the next type is half drive mode. Now in this mode, 1 and 2 coils are energized alternatively. This is different. That is, in this mode, 1 and 2 coils are energized alternatively. It means that firstly 1 coil is energized, then 2 coils are energized, then again 1 coil is energized, and again 2 coils are energized, and so on. Means, and this is a combination of full and wave drive mode. The half drive is the combination of full and wave drive mode, and it is used to increase the angular rotation of the motor. What is the use of half drive mode? It is used to increase the angular rotation of the motor. Now here are the steps. So in step 1, the logic 1 is given to the A coil. So it is a wave drive. At a time only logic 1 is given to the single coil. Then the next is in step 2, logic 1 is given to A and B, so it is a full drive. So these steps are alternative: wave drive, full drive, wave drive, full drive. In this way the working of half drive is done. Again in step 3, the logic 1 is given to the coil B, so it is a wave drive. In logic 4, the logic 1 is given to the 2 coils, that is B and C, so it is a full drive. So it is a half drive is a combination of wave drive and full drive. So in this way the half drive stepper motor work. Then the next is interfacing of stepper motor with 8051 microcontroller. Till now we have seen what is stepper motor, its modes and so on. Now the interfacing of stepper motor with 8051 microcontroller. So interfacing with 8051 is very easy. For that we just need to give the 0 and 1 to 4 wires of stepper motor according to the above tables, depending on which mode we want to run the stepper motor. Okay, this interfacing is very easy. Here we have to give just 0 and 1 to the 4 wires of the stepper motor. But how to give 0 and 1? It depends on which mode we want to run the stepper motor. And the rest wires should be connected to proper 12 volt supply depending on stepper motor. So here we have the unipolar stepper motor, and we have connected 4 ends of the coil to the first 4 pins of port 2 8051. So this diagram shows the interfacing. Here we have connected the 4 ends of the coil to the first 4 pins of port 2 of 8051 through the LN203A. So here this diagram shows the port 2 pins of 8051 are connected to stepper motor through ULN 2003A. Pin number 20 is ground and pin number 40 is VCC of controller. Pin number 20 is ground and pin number 40 is VCC. So 8051 is connected to the stepper motor through ULN 2003A. So it is a mediator between the stepper motor and the microcontroller. Now 8051 doesn't provide enough current to drive the coil. What is that ULN 2003A? The reason behind the using this ULN 2003A IC is that the 8051 doesn't provide enough current. It doesn't provide enough current to drive the coil, so we need to use a current driver IC, which is that ULN 200. So by using this ULN 200, the microcontroller will provide a proper current or enough current to drive the coils of the stepper motor. The ULN 2003 IC is 3A is a current driver IC, and it is an array of 7 NPN Darlington transistor pair. It is array of 7 NPN Darlington transistor pair, and it is constructed by connecting two bipolar transistors to achieve high current amplification. So in this, the 7 pins are input pins and 7 pins are output pins. The 2 pins for VCC and ground. In ULN, this current driver IC ULN 2003A, there are 7 pins are input, 7 pins are output, 1 is VCC and 1 is ground. So here we are using 4 input and 4 output pins. We can also use L293D IC in the place of this ULN 2003A for current amplification. So the basic use of ULN 2003 current IC driver is the current amplification, because by using only the microcontroller, it doesn't provide enough current to drive the coil or to drive the stepper motor. For that purpose, we have to use this current driver IC, that is for the current amplification. Now, so we need to find out 4 coil wires, 2 common wires very carefully, otherwise motor will not rotate. So we can find out it by measuring the resistance using multimeter. So the common wire and the other 2 wire in the same phase should show the same resistance, and the 2 points of the 2 coils in the same phase will show the twice resistance in compared with the resistance between the common point and the one end point. So this is the procedure to find out the 4 coil wires and the 2 common wires. Now, if the motor is not rotating or vibrating, but if the motor is not rotating, vibrating but not rotating, then we have to check the following things. If motor is not rotating, then we have to check the following things. The first is check the circuit connection and code. If the circuit and code is okay, then we have to check the stepper motor gets a proper supply. If the code is okay, connections are proper, then we have to check whether the stepper motor get a proper supply, that is a 12 volt supply, otherwise it just vibrate but not rotate. Then if the supply is fine, then we have to check the 4 coils endpoints, 4 coil endpoints which are connected to this ULN 2003A. First find the 2 common endpoints and connect them to the 12 volt, and then connect the remaining 4 points to the ULN 200, and then try every possible combination until motor gets started. So if we wouldn't connect them in proper order, then motor just vibrate instead of rotating. Okay, So here are the steps. If the motor is only vibrating, not rotating, then we have to check all these things. The first is the circuit connection and code we have to check. If the code is okay, circuit is okay, then we have to check whether the stepper motor will get a proper supply of 12 volt. If it is okay, then we have to check the 4 coils points which are connected to the ULN 2003A. So if these connections are not proper, then the motor will just vibrate, not rotate. Now the next is the code for the wave step mode and full wave step mode. So we can easily calculate the value for the port P2 for the half wave mode. Now here is the wave drive mode. The code is given here. The hex values for the port pins are given. So first is for the wave drive mode, and this is for the full drive mode. Again the port 2 pins values are given here. Initialization also given for wave drive mode and for full drive mode.